Afternoon, everyone. Welcome back to CRESTCon. I hope you all had a nice lunch. My name's Gemma Moore, and I'll be hosting this afternoon's presentations. For our next talk, I'd like to introduce you to Keith Driver. Keith joined Titania as CTO in 2019. He has a distinguished career in the telecommunications and security industry as a technology leader and a board member in a variety of organisations, both small and large, delivering revenue growth, technical advantage through strategy definition and innovation. He's here today to talk to us about the value of continuous auditing in zero trust architectures and risk-based situational awareness. Just a quick note for those watching, if you have any questions you want to ask about Keith's presentation, you can enter them into the Q&A box on screen at any time, and we'll have a Q&A session at the end. Slides for all presentations will be available on the CRESTCon website after the event, and videos on YouTube. Hashtag CRESTCon UK to join us on social media. Over to Keith.
Okay, I'm Keith Driver from Titania. I am the CTO at Titania, a small cybersecurity company in Worcester. Today, I'm going to talk to you a little bit about penetration testing and its relevance to the supply chain attacks and the zero trust environment that has been gathering pace in the industry for some time, and in particular in the US seems to be gaining a great deal of traction, including mentions in dispatches from President Biden in his executive order. So if I just give you a quick introduction to Titania. Titania is a company that has provided penetration test tools for the last 10 years. It's used by penetration testers and by internal auditors to look at the security of their network, particularly their core network, firewalls, routers and switches, and to look at that through the lens of either compliance or security. And the high fidelity and accuracy of Titania's reporting has been valued over the years by that community, and we are now looking to expand that capability into enterprise tools. And really that's what I'm hoping to make the argument for here today, that our industry needs to return to automation in places where it's effective and take the value from that. Okay. So again, in a conference such as CREST, it seems a little bit incompatible to start to talk about what penetration testing is, but it has a long history of measuring the security posture of systems. It's used in a number of different contexts and for different reasons, and it's matured into an absolutely crucial part of our IT industry. And it doesn't matter whether you are looking at a small part of a whole estate and testing applications, for instance, that might be deployed, looking for weaknesses and vulnerabilities in new applications or updated applications, or whether you're trying to secure a whole organization and look at its perimeter, then you have a different set of objectives. But the penetration testing and red teaming that is all part of that industry has been used effectively by large and small organizations to secure their estate and their assets. So at different times, you will use different aspects of this, but they're all important. If you're a software vendor, then you need to make sure that your software is secure, and you need the services of penetration testers to help assert that. And if you're an organization consuming software and systems, then you want to know that the integration of that and the configuration of all of that is securing your network. So penetration testing is integral to everyday modern IT delivery. In most of the time that we've been operating, the main paradigm for cybersecurity has been a walled garden approach. The walled garden is there to build high perimeter, high fences, high defenses around your assets and keep the bad guys out of your network. Now, we've all known that one wall that's very high is not sufficient or very thick, and we need to have layers of defense to address different concerns. And the layers aren't all technology layers. They are training, they are multifaceted in the IDAM space and identity access management, as well as trying to ensure that applications have no vulnerabilities or that they can't be used in a manner for which they weren't designed. But ultimately, the strategy has been to place the valuable assets in any organization, usually data, at the core of the defenses and have a multi-layered approach to defending that asset. The principle being that if your asset is in the middle of all of the defenses, then you've got the most protection that you can acquire to ensure that they are as safe as possible. And of course, we use penetration testing and red teaming to test those defenses and to try all sorts of methodologies to gain access to those assets and try and fix any problems that occur along the way. And Titania have been an instrumental part in the tools that are used by penetration testers to see if there are any weaknesses in the network configurations, along with many other techniques, including email phishing and testing the human side out, as much as any other kind of penetration or exploit tools that would allow you access to the network in a non-consensual way. So the walled garden has proved to be a long-standing paradigm, but it is starting to cause problems. So many of the attacks that have been successful in the last couple of years have managed to get through the perimeter defenses. The fact is that the attackers are continually becoming more sophisticated. So the array of tools and knowledge that they have at their disposal has been increasing for year after year. The attack surface, the ability of an attacker to look at different parts of your system, the attack surface has increased radically as systems have become more sophisticated, and the perimeter has become blurred of your network. So not only have the systems become more complicated, but their deployment has been changed in such a manner that providing walled gardens around them all has become much more difficult. So the bring your own device paradigm, where a single device, either owned by an individual or a third party from the company, at any rate, means that you're sharing the hardware platform with another presumably untrusted party, and that means that your perimeter is now on the device. That wasn't a thought process a while ago. The cloud and hybrid cloud deployment of applications, even within VPCs and VPNs guarded by networks, means that there is a much more distributed estate. It's no longer in one physical part of the world, and that brings its own issues in terms of attack surface. Many companies make use of software as a service, applications hosted anywhere on the internet, generically not within their own estate. And that means that you are accessing across the untrusted internet services that you wouldn't previously have considered being available to employees, where the applications would always be delivered from internal data centers, where physically you knew exactly where the application was hosted and the infrastructure on which it was hosted was yours. So software as a service implies a certain level of trust of that provider, and of course you've got the communications part between whichever asset you're using to access that service and the packet routing to that service. You must be trusted as well. Additionally, the modern applications are no longer monolithic. They tend to be built of a variety of different capabilities and microservices. Again, those microservices can be located locally within your own assets, or remotely on third-party provided service centres. And again, that means that no longer can you draw a perimeter around your estate quite so easily. The complex business logic to build your applications can depend on a variety of applications distributed potentially globally, but certainly not always within your estate. So a good example of that might be mapping services, where you want to depict the location of a subscriber or an asset. You might well use a tile service from another provider. And lastly, the manner in which we deploy our applications has changed radically. We talked about cloud and hybrid cloud just before, but the underlying characteristic of all of this infrastructure is that it is virtualized and that it's stood up on demand. It increases in capacity when that's required, and it can be stood up and torn down when it's not, so reducing costs to the application hosting environment. So having a completely flexible set of network assets and computing assets and storage assets means that you can build new and exciting services in a fraction of the time that you could have done it previously and for a fraction of the cost. But it increased the complexity of the perimeter and means that you have to have strategies for security and compliance that take account of all of that. And with all of that, we all know that that there have been a large number of significant breaches of these walled garden approaches in recent years. The most recent examples in the US have now brought a response from the US government. It's not evident yet in the UK that that the same kind of response is forthcoming, but the breaches in the US have been in a number of different use cases, if you like. The solar winds was one kind of breach, but the Colonial Pipeline was another kind of breach. And there are different means that these folk have managed to get into networks, each of them with different objectives. But the important part is that they all managed to breach the perimeter here. So what is the response of the IT architect to these problems? So for a long time, there has been I think since about 2013, it might be earlier than that, there has been the concept of a zero trust architecture. And the central tenets of zero trust architectures are that you must assume that your perimeter is compromised, that it's already happened and will continue to happen. Clearly, you're going to do everything you can to maintain your perimeter. Clearly, you are going to make it as difficult as possible for somebody to penetrate that exterior defense. But nonetheless, the assumption must be that it will happen and that you will be compromised. So zero trust is about micro-segmentation. In other words, building lots of perimeters around small assets so that each asset assumes that other assets are being compromised and that each access to that asset has to be re-verified and reauthorized at the point in time at which it's required. So overall, the assumption is that you must verify, authenticate, and authorize access for every time you want to use that service. And that means that it's much, much more difficult once an intruder has gained a foothold in your network to traverse that network and to make life more difficult. So in the SolarWinds case, the delivery of the SolarWinds module was what breached the perimeter, and then they spent a considerable amount of time and effort laterally moving throughout the network. And if they had been more zero trust paradigm defenses, then it would have been harder for them, much harder for them to move across the network and to to perform any of the actions or compromises that frankly still, as far as I'm aware, US government is still searching for the ultimate impact for those breaches. So not only has the zero trust paradigm been around in the industry from around about 2013, I believe, it's now been enshrined in an approach to cybersecurity that US government is supporting. So President Biden released fairly recently a US executive order on cybersecurity and supply chain risk management. And the ultimate point of that was that the US networks should adopt a zero trust paradigm. As almost in parallel to that, DISA, the US Army's information assurance arm, has been preparing a reference architecture that they want to use for zero trust. Recognizing that nobody owns zero trust, that it is a viewpoint, a way of putting things together, a view of which entity should be trusted and when and how. Nonetheless, for it all to work together, there has to be coordination and orchestration across all of the pieces. And DISA have put out a fairly weighty reference architecture. But as part of that, overall architecture, which you can see in the top right, is a migration from what will, in almost every case, be a brownfield network towards a fully matured and advanced zero trust enabled network. And penetration testing has a huge part to play in preparing for that journey, both in terms of discovery and assessing whether your network assets have the appropriate security controls, have the appropriate configurations, and you know exactly what those assets are and what they do, which of course in many networks, unfortunately, the due diligence of that is not great. So once you've done that preparation piece, then you need to baseline and understand what your network configuration is, and how it is compliant or not, and what you need to do to address all of that. So those foundational stages are ones that traditionally penetration test resources would have been used to cover, but it is an enormous task because with the best will in the world, we don't have a large army of penetration testers to dedicate to get around every piece of equipment in our networks and every piece of software in our networks. And there has to be a level of automation and reporting as a result of that, leaving the skilled penetration testers to look at the overall picture or to think more laterally about what the weaknesses could be. So penetration testing and network audit are the fundamental cyber hygiene, if you like, of preparing for the more sophisticated architectures and the delivery of applications. So it's also susceptible to automation because what good looks like can be determined by policy or by straightforward views on security. And because it's a automatable task, it means that it can be built into an enterprise application that performs exactly this task. And the industry is absolutely moving towards this level of automation. And there are large corporate entities providing capabilities that particularly address the most numerous devices in networks, endpoints, and automating patch management and the vulnerability status of applications on those devices. And where Titania comes in is that we address the core network, and that router firewall switch view is just as crucial as the endpoint view, but in days gone by, the penetration test view was to test out only a sample of the devices in the network and to look at that as frequently as possible, but that was also often just once a year. So by testing the configuration and asserting that the security status is as intended, but doing that once a day or even every hour, should you choose to do so, means that you can do it on every device every day if you have an enterprise application that can get around. And essentially that's what Titania has provided to the market. Our underlying tool, Nipper, has been used in the industry for over 10 years now, and its main selling points are that it is able to address a very wide range of network equipment and a very wide range of operating system types. So we conduct a range of different audits appropriate to the industry that you're in. So if you're in the US, the Security Technical Implementation Guides, the STIG audits are supported. We support CIS benchmarks. We have our own internal Titania security audit, which is built out of years of experience in the penetration test business and reflects the hardening guides for devices. It reflects experience and it reflects customer requests as well. So here you can see the wide range of devices that we support, and we've been very successful in the US, in particularly within in the military and the federal agencies. The thing about the US is that it is a very, if not regulated environment, it is a very, an environment that requires cybersecurity to be evidenced and recorded in a much more formal way than the UK at the moment. That's not to say that the UK doesn't care, it absolutely does, it just doesn't go about it in the same way. But in the US, Titania's customers include the forearms of the military and a whole range of federal customers, as well as a large number of commercial clients. Coming in the US is the Cyber Maturity Model Certification. This is, again, a US initiative which has reflected the defense industrial base's cybersecurity knowledge being relatively poor. So they are essentially at the moment asked to self-certify through NIST 800-171. But the US has decided, the US DoD has decided that from around about now, rolling out into different contracts as we talk, then there will be a formal external assessment of cybersecurity of the defense industrial base suppliers that provide capability to US DoD. Written into the contract will be a requirement that you meet a certain level of CMMC, 1 to 5, 1 as low, 5 as high, and you must have an external assessor that says that you meet those conditions. So Titania's tools are invaluable in ensuring or asserting that you are indeed meeting those criteria. And it doesn't matter whether you're in the US or your business is financial services and PCI DSS is what matters to you. Titania's Nipper tool has been used by penetration testers to bring about that evidence and show where there are infractions or findings that mean that you must fix them to be compliant. So we have adopted our Nipper tool and put it in a containerized format within an enterprise application. And so now we have what we're calling Nipper Enterprise. Nipper Enterprise is an application that sits on your VMware environment or in AWS or Azure as a web application. And once it's provisioned, it will allow you to audit your network estate at a cadence and on schedules that you choose. So anywhere from hourly to monthly, any kind of schedule that you like. And it has a number of sophisticated mechanisms inside it that allow you to select which devices you want to audit for under which regimes. So you might only want to audit a certain set of devices for PCI DSS, which might be your card data environment, but you might want to audit the rest of the estate for a different compliance regime. And the application supports the splicing and dicing of your network devices along those lines. Because it uses NIPA, it has access to the wide range of devices that NIPA supports. So you can audit a great deal of the installed network equipment, diverse though that may be in some networks. Of course, once you're into auditing devices at a cadence, perhaps down to an hour, but let's just say daily, you're going to generate an awful lot of finding data. And so it doesn't make sense to look at that and examine it as a report in an HTML format necessarily, but the data has been forwarded in a JSON format from the enterprise system, and so can be ingested by a number of different analytics platforms. But given that we're talking about security data here, SIM platforms are the most appropriate perhaps. And so we've built some dashboards that work particularly with Splunk and particularly with Elastic and particularly with ArcSight to visualize that data. And that gives you a way of representing risk in your network across the whole estate with no sampling at any point in time. And it also gives you the ability to look at trends and to see whether you're getting better or worse, or whether you're meeting your own targets that you've set. We've integrated with other platforms that allow you to do trouble ticketing or orchestration. So Cortex XOR we've integrated with. There's no reason why Splunk Phantom wouldn't also work. By building workflows and playbooks that take our remediation advice and then able with human intervention to be applied back down to the network devices to fix them. So why do I say with human intervention? Typically the risk appetite of network owners that we've encountered isn't for a closed loop remediation system. They want to have humans in the way that have an auditable action to approve any remediation that takes place. But nonetheless, the capability from our product is there to be able to work with source systems to enable that. And of course, the same for IT service management, like ServiceNow. So when we get findings, then those can be promoted into ServiceNow workflows and appropriate action taken. So you can imagine that maybe the SOC finds these errors and they're put into a NOC workflow for remediation. The application, of course, has to work with all of the zero trust environment that is implemented in a incumbent network. And of course, that's different every time. There's no one solution for all of that, but integrating with Active Directory, two-factor authentication, and privileged access management systems means that the NIPA enterprise fits nicely into the corporate environment and is in of itself secure, as well as exposing any problems that you have within your network node devices. So just an example here of the kind of risk overview you can get from the aggregated view. So here we've chosen to use a Splunk dashboard that we've created. The underlying data, of course, can be queried in any way you like. So there's no need to use Titania dashboards. You can incorporate our data into any of your own dashboards or workflows. But here you can see a depiction where we have separated out, for instance, the findings that we found into a risk profile view in the top center of that display, where items on the top right are the most intolerable of findings that you will find on your network. So those ones are ones which have, if exploited, a critical impact on your network. And the mechanisms an attacker needs to use to exploit them are extremely trivial. So you have a trivial way to exploit a very high impact vulnerability. And so that means that you've got an intolerable risk really on your network. And that means that you can then dive through that dashboard token and go down into the detail to find out where you need to fix those findings. And again, just as an additional example, just underneath that, risk prioritized by criticality, you can see the kinds of risks and findings that we've found and which we've categorized as being critical to be fixed. And again, you can click through these line items and find out which are the device nodes that are affected by this particular vulnerability, and all of the text and recommendations that come with what you should do to remediate that. The important part is that it's the underlying scalability of this. The enterprise system has been built horizontally scalable with, as I said, NIPA within Docker containers. So that will work across as many devices as you can manage, really, at least 200,000 devices every day, built for the largest US DoD networks on a daily basis. If you can't get direct access to the devices, then the enterprise solution will also accept file-based submissions. So if you can extract the configurations from the devices and then provide them to the enterprise system, it will ingest them and report on them just as if it had connected directly. Again, this is the same as NIPA capability. And that means that you can, if you are in the business of going as an MSSP to third-party sites, client sites, gathering configurations, and then assessing them, you can gather the configurations, submit them to enterprise as a group within a directory, and you'll get a report based on only those files separated out and visible within the SIM system, because they'll all be labeled as coming from that directory, and it means that you can separate out the views so that you can see what applies just to that client. Okay, so this depiction is really just a restatement of what we've talked about before in terms of remediation. So over on the left, we have our network. The purple piece in the middle is taking the configurations from the network devices, modeling them, then reporting findings based on the auditing that you choose, Titania security audit or STIGs or a number of others. And that then provides findings into a SIM-SAW environment that allows you to analyze what's in your network and then make decisions. Once it's in the SIM environment, you can aggregate and wash threat intelligence data over it so that you can have a much better picture of what you need to do in your network by, for instance, taking threat intelligence data, MITRE attack path, and our vulnerability data. You can take a view of whether you believe you've got a threat within your network that's live that exploits particular vulnerabilities through the attack path and prioritize remediation on that basis. So once you have the data in the SIM and SAW environment, then the opportunity is to close the loop with or without human steps, with or without the sequence, including experienced SOC or NOC personnel customizing the remediation. Nonetheless, it can be driven back into the device through our product and back into the to the network so that it's remediated. And of course, all of that is going to be audited. So I should say that the remediation step, although we have within NIPA the remediation instructions, we haven't yet implemented the return path, but we have integrated with the source systems to show that this is another short step that we'll need to take. But the future is there in terms of being able to have a high cadence of detecting anything in the network. And so a mean time to detect is very low, and a mean time to repair could be equally reduced with automation for these straightforward cyber hygiene issues that can occur within your network. Okay, and really that's all I had to say today. NIPA Enterprise is a product we'll be launching very soon. It delivers continuous audit automating many aspects of pen testing. So not everything can be audited, and not everything can be automated, and that has to be recognized at every level. Nonetheless, a good portion of very valuable security checking can be audited and can be done on every device every day at an affordable price. Affordable not just in financial terms, notwithstanding the impact of exploit, but also affordable in that it doesn't require a great deal of resources to do this. The network bandwidth use is very low. The compute resource requirements are very modest. So to get to the position where you're auditing every device every day really isn't an expensive proposition in terms of finance or in terms of resource. And it really does scale up to hundreds of thousands of devices every day, regardless of whether you're submitting them via files or via direct connection from the enterprise solution to the network devices management interfaces. Of course, any enterprise product has to integrate with the ecosystem around it, but integrating with the SIM analytics platforms means that you have a much richer picture of your cybersecurity status at that moment in time. You're not waiting, if we return right to the beginning, for a penetration tester to look at a few devices once a year. You're looking at every device every day and freeing up the penetration testers to look at much more sophisticated methods of attack or much more sophisticated methods of preventing attack. And lastly, although Zero Trust has been something that's been in the air for quite a number of years, it does seem to be gathering some executive momentum now and an expectation particularly from the US government side and US DoD side, that a Zero Trust approach will be taken to networks. And Zero Trust really means that you must continually audit your devices. If you're not continually auditing them, then essentially what you're saying is that I've configured it once, and I believe that that's correct in perpetuity. And that really is outside the Zero Trust expectation. You must continually assert that your configurations and your security status are as you think they are. Otherwise, an intruder who can gain access to, let's say, another part of the network could then change the network configurations unbeknownst to you, and you would not know then that there was a further security risk in your network without this continual checking. So I'll leave it there and open up for questions. Thank you very much.
Thanks for that, Keith. Fascinating stuff. So I've got a few questions coming in. The first one that I've got is, how will organisations transition from the old model to the new model?
So I think this is a question that comes up in almost every IT transition and transformation. So digital transformation strategies abound. We've all been through one or several, I think, in our careers. And the transition towards a Zero Trust environment will be very similar, I think, in terms of somewhat piecemeal. The networks will migrate. And as we do this, we'll bring in tools that conform and give us the foundational capacity to implement Zero Trust. So again, it's fortunate that Zero Trust isn't owned by any one vendor. So there's no real standards by which it has to conform. Although the architectures are really useful to give us design patterns. The overall participation of the whole industry in it, though, is really encouraging, and so I think you can migrate to a Zero Trust architecture and the continuous authentication and authorization, as well as the continuous audit that's needed, without too much service interruption. I think you can get there in a gradual sort of sequence of paths.
That leads me on to a sort of related question. You mentioned the pathway towards Zero Trust. And what do you think are the biggest challenges that businesses have during that transition from the sort of walled garden architecture to full Zero Trust, and the agility and the continuous assurance that comes with it?
So like most cybersecurity, it's not just the technology that's the problem. A lot of security principles, security policies, folk who are responsible and accountable for maintaining the security of a network are very much still in the mindset of the walled garden approach. Keep everything out and hunt anything that came in and comes in as fast as possible. So I think that there's to be a change in strategy of investment from the board downwards that says that we're going to disaggregate security to some extent to a zero trust model rather than investing continually in perimeter defences. For all the reasons that I outlined in the PowerPoint, it's a blurred boundary now and very difficult to protect as a single place to place your defences.
Fantastic. And how do you think the way people use penetration testers will change once you've got all this automation in place for sort of network auditing?
So I think it's a blessing, if I'm honest. Titania's nipper was invented by Ian Whiting, principally to solve a problem that he had, which was he was doing a lot of boring, repetitive work, and he wanted to do the interesting work that comes with penetration testing, the more sophisticated methods of attack. And so the tool was built to automate and make repeatable what was essentially hydraulic and error-prone work. Enterprise and its position within zero trust architectures will really just do the same, but at scale, offering, instead of just sampling, knowledge that every day you can have a view of your security posture across your network. So that leaves the penetration test community free to follow much more sophisticated attack paths, to consider the interaction of various components rather than the configuration state of a particular one. It should free our not inconsiderable but still limited capacity in the UK of penetration test capability to look at the more sophisticated problems that networks have to deal with.
And what about things like bring your own device? That obviously is something that a lot of businesses are doing more of. Are people just, refusing BYOD, integrating that into their processes? What are they doing with those devices?
So I think that's a really good question. That is the almost the most difficult boundary of the perimeter that we're trying to address. There are lots of different mobile device management solutions that claim to support that, but they all have problems in that if the person is bringing their own personal device, to what extent does the corporation own that device? And should it be the case that that person works for more than one corporation, how does that map to that particular device? So I don't think that that's a solved problem. And people's appetite for a third party to own a portion or control essentially all of the device and just allow you to use yours outside of their virtual perimeter, lots of folk don't like that idea either. So I think that it's a difficult one to bring to high security environments where we really care about security. I think that in most cases, then unless you've got very compliant and willing staff members who will accept these restrictions, then issuing of a corporate device is probably the only way forward to maintain security in a realistic sense. Everything else will be a compromise. I'm sure lots of people will disagree with me on that, and maybe there are some more sophisticated solutions that I'm not aware of, but that's my general sort of viewpoint.
I think it can be complicated, definitely, particularly when you're talking about personal data and personal ownership as well.
Yes. Yes, I mean, who owns the data? Whose responsibility is it leaks? Did it leak across the corporate boundary? Did corporate data leak across into the private boundary? It's a very difficult problem to work through.
Cool. You mentioned the CMMC and other US government initiatives. How do you expect those to impact the sort of global marketplace over time?
Yeah, so I think we were at the start of the bow wave. For anybody in the defence industry, they'll be aware of the ITAR regulations, international traffic in arms regulations, that the US operate quite assiduously. They have reached almost every corner of the globe now, because any technical data that's considered to be part of an ITAR regime has to be closely controlled and monitored and looked after. So that doesn't necessarily mean the data is classified. It just means that the US care about that particular piece of technology data. CMMC is not quite the same, but it's going to have the same kind of reach, I think, because it's being enshrined in contracts that US defence primes own, and then if you're subcontracting to them, they will devolve down the CMMC requirements to you as an organisation, and you must comply with them and have an external assessment that says that you do comply, no self-assessment, before you can participate in the contract. It's not, I'll do that as we go along, you can make sure that I'm doing it. You have to have the certificate before you can participate in that contract. And because it is a global supply chain for US DoD, then we are, particularly in the West, in Western Europe, going to be impacted by these requirements. Now, how much overlap there will be with national standards in that regard, I don't know. In the UK, our MOD has its own view of security JSP documents, and they do follow 800.171 quite a bit. But again, largely this is all driven from US contracts and US data. So I think CMMC will become quite prevalent, 12 months to 2 years out from now, as it's been woven into new contracts that everybody must conform.
So I guess time will tell. And with that, Keith Driver, thank you very much for joining us. Wonderful to hear you talk. Thanks everyone for listening. Our next talk is at 14:20.